We're going to keep moving along here to hear about the Lunar Critical Data Products findings, which will be summarized by Dr. Stopar and Stickle.
Hi, can you hear me okay?
Yes, we sure can.
Okay, great. Thank you. So on behalf of our team and my co-chair, Dr. Angela Stickle, I'll be presenting a summary of our final report from the Lunar Critical Data Products Specific Action Team report. And as Erica just said, this is a joint activity that was commissioned by SMD, TSD, and the human side of exploration as well. And it drew from both the League and the MAPSIT AG communities. And our activities primarily took place last summer during August and September. It was considered this needed to be done fairly urgently at that time. And we had a final report, which we put online as a draft right at the end of that period. And in January of this year, we had a nice formatted final report placed online publicly for everyone to see and read. Next slide, please. So why do we need this report? Well, as I think everyone here knows and understands, we have a lot of great lunar data. And so one of the things that was realized is that we need to kind of take a moment to assess those data and how we could best use them for going forward with planning, how we could best plan for getting more data in the future with all these great upcoming missions and opportunities, as well as assess whether there are any critical data that are missing. And so one of the primary goals of our work was to establish an understanding of those data, identify those gaps, but also to understand if there were any issues related to discovering, accessing, or utilizing those data that would potentially hinder planning for upcoming missions, particularly to the South Polar region. And this was done in response partially to the findings from the Artemis 3 Science Definition Team Report. Oh, and there's another little error here. I should say one of the goals of this report is we hope to be useful for NASA's planning, but also to serve as a reference for the lunar community. So you'll find in the report there's a lot of extra details and rationales supporting our findings. Next slide, please. So our approach was to address our 6 tasks. And as I said, our focus was primarily on the South Pole area, but our overall scope was broader. In total, we had 30 findings, and lots of interesting supporting information can be found in the report. Go online and read it. I'll just kind of give you highlights of the scope of what you'll find in that document. So the report summarizes the current state of available lunar data and its precision. It also includes priorities for certain types of data that we can make new products as well as create these from, as we can create much of this from existing data. And these were things that we thought would be largely needed in the near term. But we did also note some longer term data considerations, such as how to coordinate between different projects and researchers. And we started to touch on some of these concepts that were still new and in development at that time, including the planetary data ecosystem and the lunar spatial data infrastructure concepts. So we also included a few strategies for making data easier to interpret and how and also to use it when archiving and sharing. Next slide, please. So some of our key findings related to data and the products that are needed. We noted that the highly desired near-term products, especially when we're talking about the South Pole, included higher resolution topographic products at scales like 1 meter, 5 meter, 15 meters, as well as meter scale optical and radar imagery. And in addition to that, there's also a need for time-dependent environmental and situational products or tools. And these were some of the most critical near-term data products. There was also a lot of interest in controlled LROC narrow angle camera mosaics with specific illuminations for specific exploration situations, as well as polar composition, geologic maps at a variety of scales, as well as information about hazards and resources. And we also noted that initially, if there's urgency and time is limited, initial products can be less well controlled. But overall, goal should be to have a local South Pole control network, which will overall make things easier to use as well as provide more precision. We also noted that LRO can fill many of the needed data products. However, there were a few cases where there was interest in a type of data that we could not get with our current available resources, such as Earth-based radar at a variety of different wavelengths, resource, ground truth, and also field scale data. So these were the things at higher resolution than we can currently get with LRO. Next slide, please. And so related to tools and implementation, we made a number of different recommendations or findings, related to this topic, including comments on the current lunar reference coordinate frame, and that it's not super urgent, but it would be overall beneficial to update to the newest ephemeris as soon as it's convenient. And there's a fairly minor difference between those data sets, so that's why we gave it a little bit lower priority. We also commented on continuing to investigate new measurements that will further improve the reference frame overall, as well as continuing to invest in global updates to products that use the global reference and improving their control overall. And then, of course, we also dealt with some of the issues related to interoperability of the data and making it easier to use. And so we touched on concepts like recommending standard formats, and these are really critical when you're getting data from a lot of different sources and you're trying to plan using different data sets. The release data also, if it's tied with information about the reference system and frame, the provenance of the data, and uncertainty and any processing that's been done on it, this really helps overall, and you really need to include everything that makes it able for somebody else to accurately use and understand the data that they're trying to use to avoid errors. And of course, we recognized that many missions and data products do need specialized tools, but anything you can do to lower the burden and the learning curve on development, learning curve as well as lower the burden on development, this helps overall. Using standardized and common tools wherever possible is highly beneficial as well. And we also noted that, as you all know, there's a lot of things going on, a lot of different groups. We got Artemis, CLIPS, Viper, international teams working. And so now is really the best time to come together and establish some standards and best practices that will just make everything work so much better together and much easier to use now and in the future as well. And our final finding was that establishing a working group or some lunar data ecosystem could overall help and make collaborations much easier for everyone. Next slide, please.
Julie, you're at about 4 minutes over. Okay.
Oh, sorry, over? Oh, sorry. Well, here's the link to the report. Like I said, please just go read it if you need more information or ask questions. And then the final slide is a thank you to everyone who contributed to the SAT and also to the data that we have. So thank you, everybody.
All right. Thank you, Julie, for a great rundown of that SAT outcome.